Hello and welcome to the March webinar from the IEA Clean Coal Centre. My name is Debo Adams and I'm Communications Manager here. Our monthly webinars are based on our technical reports which are available from our website www.iea-coal.org. Residents of member countries and employees of sponsoring organisations can download our reports at no charge after one-off registration. Please visit our website for more details. My colleague Dr. Nigel Dong is presenting today's webinar and his topic is coal and gas competition in power generation in Asia. He has co-authored this report with Paul Barua and it's published today, so the report will be available from our website from tomorrow. If you have any questions during the talk, please use the Ask a Question box at the top of your screen. Add your email address as well so that Nigel or Paul can send you a fuller answer if we should run out of time. Okay, Nigel, over to you.
Thanks very much, Debo. And good morning, everyone. As Debo just mentioned, today's presentation is based on a recent report, and Paul and I caused it, which we will be going out today. Coal and natural gas are the two most important fossil fuels for power generation worldwide, with a share of 40% and 22% respectively in 2012. Coal is generally cheaper than gas on per gigajoule basis, but coal-fired power plants are more expensive to build than gas power plants. Moreover, gas power plants tend to have higher efficiencies and greater flexibility in plant operation. Coal and natural gas can thus compete with each other under certain market conditions. As electricity demand continues growing strongly in Asia, an important question for investors and policy makers alike is whether coal or gas should be used to meet such growing demand. This is basically what this report seeks to understand. We chose 9 Asian countries for our analysis. Because of the limited time I have today, I'm going to discuss only 4 countries, China, India, Thailand, and Japan in detail, while giving the main findings for the other countries. You can find the details for the other countries in our report. We also discussed the impact of the shale gas boom in the USA on the Asia-Pacific coal and gas market, which could potentially change the fuel market dynamics there considerably. So how do we carry out our analysis? For each country, we first analyze the generation mix and the typical power dispatch curve in order to understand the respective role of coal and gas. Second, we analyze the demand trend and supply options for coal and gas. The key analysis in this report is our modeling of the average generation cost of existing coal and the natural gas CCGT plant fleets. A high efficiency, high load case is also included to illustrate the effect of efficiency and utilization rate. Finally, we discuss other major factors that affect the roles of coal and gas in the power sector, such as fuel pricing trend, energy policy, environmental regulations, and etc. Now, let's look at the selected 4 countries. Look at China first. This chart shows China's power generation mix between 2000 and 2012. Clearly, the mix is dominated by coal. Hydropower is the second most important generation. Gas power, as shown in purple, accounts for a very small share. This is the typical annual power dispatch graph in 2013. The y-axis is the total installed operating capacity. The x-axis shows the actual hours a certain type of power plant actually operated in 2013, as well as the plant utilization rates. It's basically a different way to express the actual operation hours. Coal and lignite power plants provide base load generation, as you can see from the chart, but their utilization rates are relatively low by global standards. Gas CCGT power plants provide intermediate load, while other gas-fired power plants provide peak load. The graph also shows that the gas-fired generation capacity is much smaller than the coal-fired generation capacity. China's proved recovery reserves, gas recovery reserves are relatively small, and the RP ratio is around 30 years. Since most readily extractable gas reserves have already been exploited, future production will be undertaken in more difficult fields, and the production costs are therefore expected to increase. China has significant coal bed methane and shale gas resources, estimated to be larger than the conventional gas resources. CBM production gradually scales up, while shale gas production just started. Compared to conventional gas production, these are still at a small scale. The major barrier is attributed to above-ground issues, such as regulatory hurdles in licensing and inadequate transport infrastructure to take the product to markets, rather than extraction technologies. In contrast, coal-based synthetic natural gas is considered a more promising source of gas supply. The Chinese government also promotes SNG, but it is also aware of the associated environmental impacts and is therefore cautious in scaling up SNG production. Consequently, the SNG potential is a bit uncertain. Gas import accounts for more than a third of total gas supply in China. China has been actively constructing import pipelines and LNG terminals. Our calculation shows the total capacity of all import pipelines and LNG terminals under construction adds up to be 5 times as large as the import volume in 2013. So therefore, China's future gas import will unlikely be limited by import infrastructure, but rather the availability of gas. China's proved recoverable coal reserves rank the 3rd in the world, which can provide for about 31 years of production at the 2013 level. The Chinese government has undertaken extensive coal mining sector reforms and expansion during the past decade, which, although successfully met the increasing coal demand, resulted in severely excessive production capacity. The transport bottlenecks and the increasing production costs have led to increased coal import. China is now the largest steam coal importer in the world, but the imported volume is relatively small compared to the total coal consumption in the country. These two graphs compare the average generation cost of gas CCGT plant fleet and subcritical and supercritical coal-fired power plant fleet. The top graph represents the typical operational condition case, while the bottom graph represents the high efficiency and a high load case, which is that we assume coal and gas plants operate at the highest possible efficiency and operate at 80% utilization rate. let's look at the top graph first. It shows that the average generation cost comprises 4 components. From the bottom from the bottom up, the fixed capital cost, interest payment during construction, the operation and maintenance cost, and the variable cost of fuel. Please note these are the levelized costs over annual electricity output. So depending on the plant efficiency and the plant utilization rate. You find from the graph that the fuel cost is the largest cost component. Because gas is more expensive than coal, the generation cost of gas power is also much higher than that of both types of coal power. If you look at the bottom graph, you find this trend does not change in the high efficiency, high load case, although the costs decrease in absolute terms. Apart from generation cost, other factors also affect the coal versus gas competition. Firstly, the latest coal pricing reform in 2013 has fully liberalized the coal price. Since coal production capacity is excessive and coal demand becomes weak, the coal price is likely to remain weak in the future. In contrast, the latest gas pricing reform established a 2-tier pricing regime. The Tier 1 price is for the so-called reserve volume, which is equal to the consumption in 2012. So this Tier 1 price is regulated by the government, but the government has said it's going to increase the Tier 1 price gradually. The Tier 2 price is for additional gas volume, and the price is linked to fuel oil and liquefied petroleum gas prices. So consequently, gas price to power plants are expected to rise in the future. The second factor is China's energy policy, which aims to reduce the dependence on coal and promotes more use of gas. But the priority of gas development is given to the residential sector rather than the power sector. The latest action plan for air pollution control mandates that the coal power will be replaced by gas power in China's 3 more industrialized regions, which is the Beijing, Tianjin, Hebei region, the Yangtze River Delta region, and the Pearl River Delta region. On the other hand, the new air pollution standards and the emerging carbon price seem to work in favor of gas because coal is a more polluting form of generation without carbon capture. So the overall implication of the factors is that gas will be used to replace coal in the 3 industrialized regions for power generation. But outside these regions, gas can hardly compete with coal. Now let's look at India. In India, coal dominates power generation, but gas also has a considerable share. More interestingly, the gas power plants in India operate at very high utilization rates, 90%. You can see from the purple bar in the bottom graph. So the gas power plant operate at a higher utilization rate than coal-fired power plants, which is quite different from the common consumption of the dispatch of coal and gas power plants. India had relatively small gas reserves and mostly located offshore. Domestic gas production already peaked in 2010 and has since been on decline. Coal-bed methane development had been slow and output is small. There's no commercial shale gas production yet. There's no pipeline gas import in India, although several plans had been proposed, but no one has actually been materialized. LNG is imported through the 3 LNG terminals, and the volume is quite large. There are 3 different gas pricing regimes in India. Simply speaking, the price for domestic produced gas is regulated by the government. The LNG price is subject to the market. And in between, gas produced from cooperated gas fields with foreign companies are based on a tendering process. But overall, gas price are expected to increase. India has large coal reserves, but Indian coal tend to be low grade with high ash contents and low heating values. Moreover, the actual extractable volumes could be much less than the estimation. Coal mining is controlled by 2 companies, Coal India and SCCL. These 2 companies have failed to make the necessary investment to expand mining capacity. So the consequence is the coal import increased rapidly in recent years. Another reason for increased coal import is because the indigenous coal is of low grade, so imported high quality coal is needed to blend with the Indian coal for the Indian power plants. Coal prices are regulated by the government and kept low. There's a spot market in India which is called e-auction, but the price, the coal price sold through this spot market is much higher, but the actual trading volume is quite small. So there have been coal and gas supply shortage in India, which caused some coal and gas plants sitting idle. Our analysis shows that coal power is cheaper than gas power generated by CCGT plants. The main reason is that gas is more expensive than coal, and the trend remains so in the high efficiency and high load case. India is facing a severe power shortage and needs more generation capacity to fulfill the government's electrification target. So remember, in India, about a quarter of the population still lack access to electricity. However, the fuel shortage has constrained the government effort for capacity addition. Both coal and gas are therefore needed to meet growing electricity demand. Coal power is favored by the government due both to low cost and greater availability of coal. Different from China and India, natural gas is dominant in the power generation in Thailand. Lignite has been the second most important generation fuel, while hard coal has become increasingly important since 2000 and has been used to replace more expensive oil, for power generation. Lignite power plants operate at a very high utilization rate, while coal and gas CCGT power plants operate at slightly lower utilization rate. These three types of plants together provide baseload generation in Thailand. Thailand gas reserves are located offshore, and most gas fields are depleting. It imports gas from Myanmar through pipeline, but the gas availability there seems to reach the limit. So consequently, Thailand will increasingly rely on LNG imports to meet the growing gas demand. Thailand has only lignite reserves, which are located mostly in the north of the country. Myanmar is the only operating lignite mine, and all output is supplied to the Myanmar's power station. Hard coal import has grown fast since late 1990s, and the country now consumes 4 times more imported hard coal than indigenous lignite. Hard coal is used in power plants operated by independent power producers and small power producers. Coal power is cheaper than gas power due mainly to higher fuel costs of gas. This trend remains so in the high efficiency and the high load case. So in Thailand, gas price is regulated through a 2-tier system. Lower price is for domestically produced gas that is supplied with priority to petrochemical plants and natural gas vehicles. A higher price is for gas supplied to other users, including power plants. With increasing reliance on LNG import, gas price to power plants is expected to rise, undermining the cost competitiveness of gas power. In addition, the Thai government wants to use coal to diversify away from natural gas so as to reduce the subsidy burden. So as a result, coal is expected to play a more important role in the future. However, coal power faces strong public resistance, which is caused by the poor image of early operation of the lignite power plants. Gas and coal are the most important generation fuels in Japan. The consumption of gas increased considerably after the Fukushima incident in 2011 to compensate for the lost nuclear power. Both coal and gas power plants are operating at high utilization rates and provide the baseload generation. Even oil-fired generation operate at 55% utilization rate, as you can see from the bottom graph, which indicates the severe stress the Japanese power system experiences at the moment. Japanese have negligible proved gas reserves. Domestic gas production has been low and flat for more than a decade due to declining reserves. It relies on LNG import for gas supply and is the largest importer of LNG in the world. Over the years, Japan has managed to diversify its source of LNG supply. Interestingly, about 30% of the LNG import comes from Southeast Asia. Japan is actively involved in overseas upstream sectors, notably in Australia, to secure its gas supply. The power sector is the largest user of gas in Japan. Japan pays the highest price for LNG in the world, which is indexed to oil prices. The Japanese LNG price forms the basis for the LNG price in the Asia market. In recent years, Japan has attempted to delink with oil and base the contract LNG price on gas hub prices with limited success. Coal import provides all of Japan's coal supply, and Japan is now the second largest coal importer after China. Its source of coal import is less diversified, with the majority comes from Australia, followed by Indonesia and Russia. A collectively negotiated reference price between Japanese utilities and Australian suppliers is used for long-term coal supply contract, and this is reviewed annually. The importance of long-term contract and the reference price has reduced in recent years, due mainly to the ongoing liberalization of the Japanese electricity market. Moreover, the spot market purchases are becoming increasingly important. Gas power is more expensive than coal power, due mainly to few price differences. This trend remains the same in the high efficiency and high load case. Japan already has more installed gas-fired generation capacity than coal-fired generation capacity, almost double. Coal power is cheaper, even though gas CCGT plants operate at very high utilization rates. However, Japan is building more gas-fired power plants than coal-fired power plants. There are two reasons for this. First, the Japanese government energy policy, particularly with regards to nuclear power, is still uncertain. So the Japanese utilities opt for gas power for new builds, because gas power plants have lower capital cost than coal-fired power plants. The second reason is the carbon tax introduced in 2012, which makes utilities in favor of gas power as well. Currently, gas CCGT plants run as baseload and determine the electricity market clearing price. So this suggests the gas power plant may be operated profitably on the current market conditions. Now let's move on to the other countries. I'm going to go through the main findings quickly. The three countries shown on this slide, Indonesia, Malaysia, Vietnam, are facing a quite similar situation. Although gas is cheap, so gas power is cheaper than coal power, they are using more coal to meet growing electricity demand. The major reason is the perceived gas supply shortage and the rise in gas prices, because more LNG import is required in the future. In contrast, coal supply is more abundant, and the coal price is lower and less volatile. The Philippines does not subsidize fossil fuels, so therefore, in this country, the choice between coal power and gas power depends primarily on the generation economics. Because coal power is more economic, coal is widely used in the Philippines to generate electricity. Gas power concentrated in the province of Batangas in the Luzon Island. The gas price is expected to increase as more LNG will be imported. The majority of coal is also imported, so the coal price to power plants in the Philippines is subject to risk in the international seaborne market. Coal is the most important generation fuel in South Korea, followed by nuclear power and gas. Gas power is almost twice as expensive as coal power, because similar to Japan, it pays the highest price for LNG in the world. Nuclear power development has been scaled back following the Fukushima incident. So this makes coal favored by the government in its plan for new built power plants. Okay. The shale gas boom in the USA has not only changed the energy sector dramatically within the country, but also has strong implications for coal and LNG markets in Asia. No gas price have led to fuel switching from coal to gas for power generation in the USA. So this makes more steam coal available for export. But the major issue is the lack of port terminals on the west coast, which are dedicated to exporting coal to the Asian market. The 5 port terminals have been proposed, but are facing regulatory hurdles and local resistance. So only one port terminal is likely to proceed to construction. The large price disparity between the Henry Hub price and the LNG price in Asia generates huge interest in exporting LNG to Asia. There are 14 proposed LNG export terminal projects. Most of these are based on existing regasification terminals to make use of existing facilities. So far, only 4 projects have been approved by the Federal Energy Regulatory Commission. Because the government is cautious about the potential impact of exporting LNG out of the country, such as the concern that the domestic price might be pushed up. So the government has authorized LNG exports to non-free trade agreement nations with accumulated volumes totaling about 59 BCM per year. Additional export volume authorization will depend on whether the cumulative export volume will have any adverse impact on the public interest, such as increase in domestic gas price. External factors such as the speed of price convergence in global natural gas market and the pace of gas supply growth outside the USA would also contribute to the uncertainty of LNG export from the USA. Okay, conclusions. In countries where coal already dominates power generation, it probably remains so in the future. In other countries where gas is dominant, coal appears to be favored for future new builds. In Japan, since its situation is a bit different, gas seems to become more important due to uncertainty over its energy policy and the carbon tax. The generation cost is primarily the factor determining the generation cost competitiveness is primarily determined by the fuel cost. Utilization and efficiency can change the relative cost differences, but the trend seems to remain unchanged. Generation cost alone does not determine the coal versus gas competition. Other factors such as fuel supply options, pricing reform, government energy policy, environmental regulations, and etc. are needed to be taken into account. The USA could potentially become a large exporter to the Asia-Pacific region, but its impact remains small at the moment. So that's the end of my presentation. Thank you for your listening. My colleague Paul Barria is sitting by me, so we now can take questions.
Thank you very much, Nigel, for an excellent, thorough presentation. I'd like to just stress to any listeners that all countries are covered in equal amount of depth, but Nigel didn't have time to go into that for all 9 of the countries covered. And as he said, Paul is here, so they can both answer questions. See, we've got quite a few come in. So I'll start with the first question. Don't know which of you wants to answer it. In Japan, does either of you know how much is the carbon tax, and is it set to increase?
If I remember correctly, it's about $2 per ton. Well, I think it's probably gonna go up, but it really depends on the kind of joint between the public utilities and the government. Japan has mandated to reduce its greenhouse gas emissions by about 20% below the 1990 levels. So the carbon tax is a measure to ensure that target is going to be met. But well, we'll see. I can't say, but most likely going to go up.
Thank you, Nigel. The next question says, you mentioned that gas generation load factors are higher than those for coal in India. Do you know why that would be? Gas generation load factors.
Yes. If you look at more carefully, you'll find the gas power generation concentrate in just a few provinces where closer to the gas fields. In these regions, there are no alternative generation plants. That's why, and because the electricity demand is growing so strongly. That's why these gas plants are operated at a very high utilization rate.
Thank you. There's another question coming. This one is about Japan. The question is, does the coal versus gas competition in Japan create a ceiling price for the coal? Paul's going to answer this one.
Hi. I suppose the short answer is we don't really know for sure whether that would be the case. It's a very good question. One thing we do know is that the LNG paid by the Japanese utilities is probably some of the highest in Asia. So there is absolutely no doubt that yes, there is some coal-gas interaction. But as Nigel mentioned in the presentation, the near elimination of nuclear means that Japan's one of those cases where we probably haven't seen quite as intense coal and gas competition, simply because both sources are required to try and maintain some sort of robust power generation supply. The coal negotiations, in terms of coal price, will it go up in the light of high LNG prices? That's really dependent on the reference price negotiations that happen annually, and it seems to be set by a completely different set of dynamics, where it will be based mainly on Australian export coal costs, and that is generally one of the major key drivers. And of course, exchange rates is one of the critical factors there as well. So that's a very good question. I think it's one of those areas where if we do focus more on Japan as a country alone study, I think we will definitely take on board that comment. Thank you.
Okay, here's the last question that's come in and that we'll have time for today. The question is, are there any environmental regulations or constraints on electricity generation in India? I would say that this question is slightly outside the scope of this report, and we have got more work on environmental regulations and emission limits on our website. But if either Paul or Nigel have anything to add to that. I'll offer it to them. Do you want
well, I think because the environmental issues caused by using coal for power generation have been quite severe in India. So particularly the sulfur. So the India government has released has required the generators to put on the desulfurization equipment to reduce the sulfur dioxide emissions. And in addition, there's also requirement to reduce the particulate emissions. So these two are the two pollutants that have been required by the government to reduce emissions. For other pollutants like NOx, currently there are no such regulations. I think the Centre has published a few reports on the air emissions issues, so you can check the report for details. Thank you.
Yes, exactly. I agree with Nigel. There will be regulations and limits. They're just not all covered in this particular report. That just about wraps it up for today. If you have any more questions or comments, please email Nigel at the address on this last slide, and he'll get back to you. As I said, the report will be available to download at no charge to residents of member countries tomorrow. And our next webinar is a very different subject. It's on Wednesday, 22nd of April, when our colleague Xing Zhang will report on the subject of her recent work, which is microalgae removal of CO2 from flue gas. Thank you very much for listening. Goodbye.